All right, well, welcome everybody to the latest office hours iteration. It's been a little while, there was a bit of a gap. It's been a relatively quiet period in California. That's part of the reason why, although it has not been quiet at all in a national or global context, that's for sure. Just about every kind of weather extreme you can think of under the sun has been prevalent really everywhere else in recent weeks and months. So California, of course, has been unusually cool. It's been a pretty chilly early summer period. Not record-breaking cold, but definitely colder than average. And that is in great contrast to much of the rest of the world, where many places have been seeing record-breaking, even record-shattering heat waves in recent weeks and months, including some parts of the US and Canada, where Texas, most of the state of Texas and much of northern and northeastern Mexico, for example, are currently experiencing a heat wave that just won't end. And some cities have hit new all-time record high temperatures on multiple consecutive days. We've seen a number of record-shattering heat waves like that in recent years, and this is yet another one. The interesting bit is that California really is the exception. There are very few other places on the earth right now that are even nominally cooler than average. California is definitely one of them, and parts of the western U.S. actually more broadly, I think would be a more accurate descriptor of the region that's currently affected. But the interesting bit is that we're seeing heat waves, as I mentioned, in Texas, record-breaking heat in western Canada, more briefly in eastern Canada, portions of southern and western Europe, South Asia, and in particular, most of the world's population has experienced record-breaking heat in recent days because South Asia, in particular India and Pakistan, as well as much of China, including the interior northern highlands of China, have experienced exceptional record-breaking warmth once again. And several countries recently have experienced including a couple of small island nations, their hottest temperature ever observed, partly because the global oceans are also at record warm levels. Again, one of the only patches on the Earth where the ocean is currently near or below average temperature is right off the coast of California, which is one of the reasons why California remains cooler. But that is an extraordinary contrast to almost everywhere else on the planet right now. And there's been a lot of discussion of this. Last time I talked about some of the lesser known potentially contributing factors to why the world is so exceptionally hot this year. There's been a lot of attention paid specifically to why the North Atlantic in particular has been so exceptional. But the reality is that most of the global oceans, with a few exceptions regionally, are just incredibly warm right now. And so the global aggregate, of course, is record warm. Programming feedback here. Folks are saying the audio is good and the video is not so good, which is consistent with what I can see on my end. I'm not sure why that video is so bad, but let me briefly just see if I can tone down the video quality right now and see if I can improve that, since I know folks do rely on the video here, so I don't want to completely kill that off. Yeah, it's laggy on my end as well, so it's getting to the point where I should probably have a dedicated machine for streaming video, because it seems to be too much to ask for a modern laptop to do streaming video and to really do anything else. I don't even mean simultaneously, but I mean in serial. Anyway, I'm just trying to slightly decrease the encoding so it goes a little bit more smoothly. I won't spend any more time, I won't waste any more time with that. And yeah, we'll go from here. Next time the video will be better. I honestly think we can blame the garbage truck that knocked over the telecommunication lines. Okay, so just to sum up, there are lots of record-breaking global warmth embedded within that, some record-breaking flood events. Often in most places in the world, record-breaking heat and record-breaking precipitation go hand in hand. Not so much in California. That is one of the few places where it's usually cooler amid very moist atmospheric conditions. But in the rest of the world, often you do get these extreme precipitation events in the same window that you get for the in which you get the record-breaking temperatures. So there have also been some major flood events as well, coinciding with these episodes of record heat. And all the meanwhile, there is, of course, a still developing El Nino event in the tropical Pacific Ocean. And that event is continuing to intensify, and all available evidence continues to point towards further dramatic, even strengthening in the weeks and months to come. And the big challenge is that there's going to be a bit of a rift between we call the process-based dynamical model predictions and the more observationally constrained statistical models. So the statistical models don't know anything about the physics of the atmosphere or the ocean. They just know they're based on historical relationships. But the dynamical models, which is what we're usually talking about, these are the seasonal climate models or that are essentially extended versions of weather models. Those are the ones predicting an exceptional El Nino event right now. So there is near unanimity among the dynamical process-based models that we're headed for a strong to extreme El Nino event this year. The statistical models, they all still agree with El Nino of some magnitude, but some of them cut it off at a more moderate event. I'm at the point where, based on what we're seeing in the ocean and the atmosphere, that I tend to think that the predictions for a much stronger event are more likely to come to pass. So I think it's highly likely we will see a strong El Nino event this year. We're already seeing an El Nino event of modest magnitude at the moment, but that is something that is going to continue to intensify. So that is driving a lot of what we're seeing. El Nino events in general amplify the warmth, both initially in the surface oceans and then later in a lag sense in the atmosphere. That lag is because, of course, it takes some time for that extra heat near the surface of the ocean to actually make it into the atmosphere and be moved around by wind currents and mixed into the vertical atmosphere over months. El Nino itself is essentially liberating some of the heat stored in the subsurface ocean and bringing it to the surface. That's sort of what El Nino does and how it sort of functions. That's its role in the global climate system is moving some of the energy up from depth and dumping it into the atmosphere. That's why when we do get these episodic, semi-cyclical El Nino events, those tend to be much warmer in general than La Nina years in an equivalent time period. It used to be, prior to strong human-caused climate change, that the warmest years were always El Nino years, essentially, and the coolest years were always La Nina years. That's still true in a relative sense in any given decade. So in the 2020s, for example, the El Nino years are likely to be the warmest years of the decade, and the La Nina years the coolest years of the decade. But now, even the La Nina years are much warmer than almost all years that we experienced in the 20th century. So really the difference is now El Nino years are record-breaking warm years, and La Nina years are simply among the top 10 or 20 warmest of the 20th century instead. So again, we're sort of, that's the main driver where we're that's sort of modulating these year-to-year variations in how warm it is. Of course, the long-term driver is human-caused climate change, where we're sort of stair-stepping up along that inexorable upward trend. El Nino represents the exclamation point on that trend. La Nina is a bit of a diminutive note, if you will. So El Nino is a big part of what's going on, the long-term warming trend, and the fact that El Nino is liberating a lot of energy that had been stored in the global oceans, partly accumulated due to climate change. So this big El Nino event and all future El Nino events will be the years in which a lot of the warming that got stored in oceans below the surface comes to the surface, and when we experience it in the atmosphere, that's one of the reasons perhaps why the global models are going so nuts with their predictions for this year. And last time I talked about some of the other potential influences, the potential short-term, by short-term I mean maybe 2 to 5 year long, modest warming effect of the Hungatanga volcanic eruption last year, which very uncharacteristically for large volcanic eruption actually injected lots of water vapor into the stratosphere rather than sunlight reflecting ash. And of course water vapor is a greenhouse gas, so there might be some additional warming from that. And by some, I mean probably on the order of 0.05 degrees centigrade in a global average, something on that order, which doesn't sound like a lot, but when you add it onto everything else that's going on, it perhaps isn't negligible. It noticeably increases the likelihood that Earth exceeds 1.5 degrees centigrade of global mean warming on a sustained basis relative to that volcanic eruption not having happened this decade. So it isn't the cause of long-term climate change, of course, but it is a cause of potential short-term climate change that may, at least in the short run, reinforce the warming that's occurring due to human factors. We also talked a little bit about the hypothetical influence of changes in shipping, pollution controls in recent years, and the fact that the sunlight reflecting sulfur aerosols have decreased fairly quickly, coming from ships at least. But that too is an effect that is of uncertain but very likely modest effect. It would be an additional warming effect, perhaps on a similar order, a few hundredths of a degree centigrade, maybe as much as 0.05, 0.06 degrees centigrade, which again doesn't sound like a lot, but you start adding these things together, you add it to human-caused climate change, and the effect right now globally is not so negligible, given that we're also getting unlucky or random chance is giving us an El Nino event this year. So this year there are at least 4 different things that I can think of, obvious things, some of which are natural, some of which are human-caused, and the primary one of which is still long-term warming caused by greenhouse gases, are all acting in concert to bring about what globally will be probably a very warm period for the rest of the year into next year. Record warm likely by early next year, and even in places that aren't now. What's interesting though, California's experience right now is a great example of how not any individual region doesn't necessarily experience conditions that are consistent with the global mean. California has not been exceptionally warm in recent weeks and months. In fact, it has been quite cool. California experienced its coolest winter in 30 to 40 years, depending on where you were. The spring has been cooler than average, and now the summer is also starting out to be, in most places, cooler than average in California. And some parts of the West. And so just an illustration of how your mileage may vary, but in general you can't really interpolate what's going on globally from what's happening in your neck of the woods, at least on an instantaneous basis anyway. The interesting piece about that is that it brings up a question that I think has already shown up in the comments today, and I will, as I always do, go through the comments sort of after the monologue portion of this is done. El Nino does not necessarily mean a very hot or warmer than average summer in California. In fact, there have been some significant El Nino events where the opposite is true. Now, of course, we have all these other competing factors globally, which are acting to increase global average temperature. So it's not like we're going to see a record cold summer or anything, but I'm not so convinced it's going to be especially warm. There were already indications that the first half of summer might be at near or below average. So far that seems to be essentially panning out. And the interesting bit about that is that there may be some link to the atmospheric circulation changes that come about as a result of a strengthening El Nino event. So we know that El Nino essentially strengthens the Hadley cell and sometimes can accelerate that subtropical jet stream. Normally, during a strong El Nino event, that would be why we would expect to see wetter than usual conditions in central and southern California during a strong El Nino event during winter. That doesn't really bring wetter than average conditions in summer, because in summer the average is pretty close to zero, so it doesn't mean that much. But what it can do is sort of prevent certain ridges from becoming persistent and from bringing extreme heat waves. So you can actually get El Nino that brings cooler than average summers because it sort of amps up coastal upwelling due to northwesterly winds and prevents some of these midsummer ridges from becoming particularly intense or persistent. So that may be part of what we're seeing right now. Not fully sure if that's the entire explanation, but there's a good chance that's part of it. We've also seen some unsettled conditions continuing in the mountains and sometimes beyond the mountains later in the year. That also might be something that a developing strong El Nino event might favor. All of which is to say, there's not necessarily an increased likelihood of a very hot summer in California this year. In fact, it may be somewhat less likely than some of the recent searing summers that we've seen. But that said, in the short term, there is a heat wave coming, and that is one thing I wanted to talk about this week. A significant heat wave, in fact, for the interior of California, particularly the Central Valley and the Sierra Nevada foothills. This does not look like it's going to be an extreme or historic heat event, unlike so many events we've seen in recent years. So I don't think we're going to be talking about any record-shattering temperatures. In fact, a lot of places probably won't even break daily records. But there's a chance that a couple places could break a daily record or two by a degree or so. And it will feel hotter than it is, of course, because it's been so chilly even as of late, that the transition will feel rather sudden. So it will be in the triple digits, and in some cases well into the triple digits in places like Sacramento and Bakersfield and Redding, as well as some other spots. And folks, this will be the first triple digit day of the year in some of these places. And there will be increased heat stress and heat risk associated with this event. It's a little bit disproportionate for what it would normally be this time of year, simply because people haven't acclimated to it yet. So this will be a significant heat event. It'll be in the triple digits inland in a lot of places. Doesn't look like anything earth-shattering, but be careful with it anyway, because most people are not used to the heat yet in California because it's been so cool recently. This heat wave looks like it'll build into the weekend, the coming weekend, and peak probably on the weekend. So significant amount of heat for the holiday weekend coming up. I believe that's this coming weekend. Yes, it is. I had to look at my calendar on the wall. That does mean that there will probably be more wildfire starts. This does not look like an extreme wildfire risk pattern. I don't foresee any really strong winds or incredibly low humidity events or dry lightning events. So those are the three things we usually look out for widespread dangerous fire outbreaks. Don't see any indication of that. Also, in most places, vegetation is a little bit moister than it would usually be at this point in the season. So it's almost as if this heat wave were happening 2 to 4 weeks earlier in the season, not in late June and early July, but actually feels more like early June maybe in terms of vegetation moisture. That doesn't mean there can't be fires. It doesn't mean the grass hasn't dried out enough to carry a flame, so there probably will be some. And as we know, 4th of July weekend, within about a week of 4th of July, there are a large number of additional wildfire ignitions because of, you guessed it, fireworks. You can see this in the plots of the number of fires started daily. There is a huge national spike on the 4th of July. It's the day of the year usually where there's more fires started than on any other day of the year. The good news is that 100% of them are avoidable, but of course lots of folks tend to do things that don't avoid them. So there will be hot and dry conditions leading into the 4th of July. Things tend to get hotter as you get closer to the middle of summer, so fire risk increases incrementally. And then we get the big risk events with either A, dry lightning events, B, extreme heat events, or C, extreme wind events, which usually occur late in summer and early fall. So we're not right now seeing those extreme events, even though we are going to have a major heat wave coming up, which will probably lead to some fire starts and dry things out even more. So not a crazy event, not a heat wave that would probably make the news even in a lot of cases, but something to be aware of and to be careful with, because it's been cool as of late. So there is, in addition to that, what else is going on? We've got the wildfire situation in Canada just continues to be completely off the wall ridiculous. It's pretty. I think Neil LaRue just posted a graphic. We have satellite records of wildfire radiative power, essentially an aggregate measure of both size and intensity of fire. Canada, we have a record going back about 20 years from satellites. The current value to date, as of June 25th, is now more than double that the previous record calendar year. So we are just completely obliterating records in terms of the level of wildfire activity in Canada this year. And it's showing no signs of showing. Most of the major boreal forest regions in Canada that are currently on fire are going to be unusually hot, unusually dry for at least a couple more weeks, and probably for much of the summer. So, this is probably going to get even worse before it gets better. This is sending lots of smoke. Cities in Canada are having just unceasing wildfire smoke crises, public health crises. It's very, very similar to what California and the West Coast have experienced in other recent years this decade. This is what's going on in Canada right now, where there's a record-shattering wildfire season unfolding. Though smoke is affecting occasionally the northeastern U.S. You've seen the headlines about New York City and D.C. Being smoked in. That'll probably happen again as wind currents favor it later this summer, because the fires both in western, central, and now eastern Canada as well, they're not going to go out anytime soon. These are not extinguishable fires for the most part. They're in remote areas with extremely dense vegetation, including both dense coniferous forests and peatland in some cases, hundreds of miles from substantial population centers. So these fires are pretty much going to burn until the weather is favorable for them burning themselves out. And in some places that won't be until the snow falls in fall or winter this year. So that's going to continue to be a globally significant story. We've now heard a number of plantation forests, both for timber and also specifically forests that are allocated for carbon offsets, which is a very controversial topic, I think, for good reason these days. Some of those forests have gone up in smoke, and those carbon offsets are not so offset anymore. This has long been a concern of foresters and ecologists and fire scientists and climate scientists that has gone widely under-recognized. A lot of those carbon credits don't actually exist anymore after some of these fires. We've seen this before. We'll probably see more of it in the future. Topic for another day, but I just thought I'd throw that out there. Glad to see the video and the audio have synced up, by the way. Getting a couple of comments about that. Let's see, anything else that I wanted to talk about in terms of California? I think we've covered everything that I wanted to in the monologue, so I'm going to start going through questions now. Pretty good turnout today. Maybe it's because I built up some anticipation with a 2+ week gap. Yes, lots of comments. Okay, I'm going to go generally in order, so I think there's enough time to get to everybody who said something as of now. We'll see if I can get to everything that people mentioned thereafter. All right. Well, the first question is, why is California going to be hot all of a sudden? Can we stay cold for at least the summer without heat waves? Well, it would be pretty hard to go a whole summer without heat waves in California, but as I mentioned, I don't necessarily think this summer is going to be unusually hot overall. It's already started off relatively cool, and this heat wave looks pretty ordinary, really, for July, late June, early July. Not extraordinary. So, in that sense, this is pretty typical, and it probably won't last indefinitely. In fact, there's some indication that we may go back to a relatively somewhat cooler than average pattern, especially along the coast by after this heat wave ends in early July. So you might get your wish, and the summer doesn't necessarily look unusually hot. I do think there's a higher odds of an unusually warm autumn in California, but we'll cross that bridge a little bit later, I think. Follow-up comment that people won't be ready for this heat after it's been consistently cold in California. Yes, that's true. This is one reason why the local weather service offices are emphasizing the heat risks, even though everybody who's lived in it's just that, each seasonally, the human body, I experienced this. It's been unusually cold on the Colorado Front Range as well recently, and then we had a single 90-degree day out doing some yard work and realized that I have not acclimated to the heat yet this year. Whereas, at other times, as recently as last year, 90 degrees would have been pretty unremarkable and would have not been too much of an issue. So this is something, that's why it matters. It's not that humans can't handle 90 or 100 degrees. It's that if you go quickly from chilly temperatures to 100 degrees, then you're going to have some more problems potentially. So take it easy. Let's see here. I'm going to continue to go down the comments here. Yeah, the comment from Stony about the very hot temperatures in Hermosillo, Sonora, just south of Arizona on the west coast. There have also been similarly extreme temperatures in northern and eastern Mexico in recent days. And in Texas, as I mentioned. So this is part of a contiguous region of exceptional record-breaking heat. There's sort of a subtropical heat dome that's set up here. Heat indices, by the way, so the combined effect of temperature and humidity in some parts of Texas and the coastal plain of eastern Mexico right now are exceeding 120 degrees Fahrenheit for days on end. Absolutely miserable. And there is a real concern that the Texas power grid, which again is isolated, it's not interconnected to the power grids elsewhere in the U.S. for reasons, is vulnerable in events like this. And there is real concern that as the peak electricity demand continues to rise, a bunch of gas and coal plants are currently offline, and so that's there's potentially not going to be enough supply to meet electricity demand in Texas, and that could cause rolling blackouts right when people critically need air conditioning. 120 degree heat index is actually very dangerous to not have any access to active cooling in, and so yes, that's likely to be an issue. But meteorologically speaking, there has been a broad sort of subtropical ridge over northern Mexico that's extended really almost all the way from the west coast to the east coast of Mexico, and northward into Texas as well, and it's just been really persistent. So as the subtropical, it's sort of possibly the result of some anticyclonic wave breaking. So the subtropical jet has been, as I mentioned, more active than usual, but in the locations where that jet locally terminates, you can get some anticyclonic Rossby wave breaking, and you can sort of build up a downstream ridge. I think that might be part of what's been happening as the El Nino circulation pattern takes hold. But there's probably something else going on because, again, that might explain an ordinary heat wave, but not a record-shattering heat wave. Part of why an ordinary heat wave becomes record-shattering is you can chalk it up to climate change. It's just warmer than it used to be, and so similar atmospheric circulation patterns can bring about unfamiliar record-breaking temperatures because the baseline is higher. But there could also be some other things going on. The atmospheric circulation pattern around the northern hemisphere this spring and early summer has been pretty wonky, to put it scientifically. It's been very wavy. There has been some research suggesting that summertime wavy jet stream patterns may be more common in a warming climate as the meridional temperature gradient shifts. This is something that has been really only strongly indicated, though, in summer, although we are entering summer, so this does potentially become relevant. Still an active area of research. There really isn't a consensus on this because we don't understand the underlying processes very well, and we can't simulate the underlying processes perfectly, so that makes it difficult to make predictions sometimes. But that could be playing into it. But proximally speaking, sort of a subtropical heat dome anchored across northern northeastern Mexico is proximally responsible for this record-shattering heat. I haven't looked specifically at the numbers, but I do know that many places, even high elevation places, Mexico City, which of course, lest folks forget, is over a mile high. Mexico City is a very elevated major population center, vertically speaking, and it saw its hottest June temperature on record. I believe it was around 95 degrees, which again doesn't sound like that hot until you realize that this is the equivalent of somewhere pretty high in the Tahoe Basin, above lake level, being 95 degrees at present. So it's a fairly big deal there. And so there's just been a lot of record heat in that, as well as Oceania, so many island nations, record-breaking and even record-shattering heat. The story is similar in each of these locations. All right, here. Yeah, Stoney mentions that in Hermosillo specifically, it got up to about 115 degrees Fahrenheit. I don't know the specific numbers, but that is extraordinary, really, for any coastal location, really almost anywhere on Earth. My guess is that there was some. I don't actually know this specific event, but my guess is, just given the geography, there was probably some sort of downsloping wind event, kind of similar to the sundowner winds in Santa Barbara County, where you can get compressional heating of air, and you can get temperatures that skyrocket to, or sometimes at least briefly, to ridiculous levels. Like it can get to like 110 degrees or even hotter, right down at the beaches in Santa Barbara, even when the water temperature is like 70 degrees, because the wind is not blowing from the water, but you have sort of this artificial bike pump-like compression effect of the air falling off the mountains, descending, compressing, heating, and then bringing extreme temperatures to coastal areas. So that would, without actually having looked at the weather maps, that would be my guess as to what happened. Potentially facilitated by this very hot and dry air mass across the interior of northern Mexico that might have led to that. But I can take a look. I would need to look at the geography and the weather maps a bit more closely. Yeah, folks mentioning that they're grateful that the Bay Area was mild in June. Yeah, I mean, it's nice to sometimes not have extreme weather to deal with. Benign weather is sometimes a godsend, especially after the last decade. It's been rough for a lot of folks in California. I mean, even after the last year, honestly, this was a rough winter, so you might as well take advantage of the cool and unsettled spring and summer, because at that time of year, that becomes the benign side of things. All right. A couple of folks mentioning the Haydn force. I don't know what that is. It's potentially referring, maybe that's a reference to the Hadley cell, the Hadley circulation. Essentially the permanent vertical circulation feature that brings air from the tropics poleward in both hemispheres at the upper levels of the atmosphere and results in descending air in the subtropics. California is kind of at the margin there in that descending zone, especially during the dry season, which is in fact why we have such distinct dry seasons. Perhaps that's it. Not quite sure, but I can look into that. There may be a clarifying comment further down, so I'll take a look. I'm still only halfway through the comments here. Yes. All right. Folks mentioning, it looks like it could get up to 110 in places like Redding this week. Keep in mind that Redding is a very hot part of California, so 110 is, it's hot for sure, but it isn't necessarily record-shattering. We'll see how much. If it gets much hotter than that, then there's a chance it could potentially break a daily record or two, but definitely not a monthly record, since again, it's a pretty toasty place. Alrighty here. Clarification, so the dynamical models I referred to earlier in this conversation, those are the process-based physical models that take the laws of physics and chemistry and convert them into predictions by initializing the current initial state of the atmosphere, the oceans, etc. As input data, and then predicting forward in time according to those physical laws, essentially. The statistical models aren't necessarily based on physical laws. They're based on observed historical relationships. Those are much less sophisticated models than the dynamical models, and I tend to believe that they won't necessarily produce as good of predictions under unusual, or even, as we're currently experiencing, historically unprecedented combinations of record-breaking ocean warmth and El Nino in some regions and relatively cool places in others. So I almost always tend to lean on the dynamical models, and I think this year they're probably even more likely to be. All right, here. So there's a comment from. I just lost it here. There's a comment from Fran that the San Francisco Bay water levels have been elevated since April and are comparable to 97, 98. I actually don't know about that. I have not heard anything about that. I can take a look. I would be a little bit surprised if that were true now, because the coastally trapped Kelvin waves don't appear to have made much progress up the coast yet, and the near shore water temperatures are pretty cool. The bay can always do something slightly different in terms of temperature, because there's not really upwelling from northwesterly winds in the same sense that there is offshore. So they may be a bit warmer than average compared to the cooler than average coast, but I'm not sure about the water level. That's an interesting point. I'll have to check in on that. If anybody has a definitive source for that, I can take a look if you post it in the comments. From Lauren, is it too early to say that El Nino is playing a role in the heat waves in Texas and Asia? No, I think how big a role, quantitatively, is something that you would probably need a scientific study to state unambiguously, but I think it's fair to say that El Nino is playing a role. It's just not clear necessarily how large that role is, as is climate change. Climate change is playing a role in these and essentially all heat waves on Earth now. So it may have been that these heat waves would have been significant but not record-breaking during a similar El Nino event 30 or 40 years ago. So I would say probably the two most important factors would be climate change and El Nino. And then there are these other lesser factors or more uncertain factors that I've been talking about in the past. But yes, I think that's fair to say, as long as we mention climate change in the same breath, because there's just as much evidence that climate change is part of what's going on as there is El Nino in cases like that. Comment from Noah about the New York Times Magazine article that came out. I believe this is the one on dams in California and the risks that they could potentially pose given an extreme storm, and a bit of a deep dive into the politics there. That's something that I have become pretty enmeshed in recent years, working with a lot of the folks quoted in that piece, and this is directly relevant to Arc Storm 2.0, which many of you are familiar with, that extreme storm and flood scenario for California. That is still ongoing, by the way, because it's been really, really, really difficult to get tangible support from agencies. The Department of Water Resources in California is and has been supporting it, but that is so far essentially the only one, and so we're still trying to wrap this project up and actually do the flood modeling that follows the storm modeling that we've already done, published, and talked about extensively. But Noah's question is, do you agree that there's something of a weird Chinatown vibe, which I believe is a quote, safety are brought up with public officials? I see my connection is weak again, so I'm going to pause for a second just so that it can collect itself. Yeah, just reflecting on Noah's comment now that the connection seems to be back, regarding the quote weird Chinatown vibe when it comes to dam safety and flood risk in California, and I think that's a fair statement. I've definitely gotten some weird responses that are pretty different than the kinds of responses when I talk with folks, including folks who work in the space, about other kinds of natural hazards, like wildfire or earthquake risk or something like that. So I think I think that there were at one point, and perhaps still, national security concerns about going into the details. And some of that information is not public for ostensibly national security reasons. I think that's one piece of it. I don't think that's the whole story, though. I think that there are other reasons why dams are a touchy subject in a place like California because there are so many of them. They're so integral to California's functioning. They are viewed in many circles as being essentially invulnerable. I'm not an engineer, but I can tell you that all engineered structures do have limits. The question is whether those limits are reasonably high. If, for example, if you have a flood culvert on a street, a stormwater culvert, you might build that to accommodate the flows of water you'd expect every 5 to 25 years, right? So depending on where you are. So something that, in the average year, it shouldn't be overtopped, there shouldn't be flooding. But, over the lifetime of that infrastructure, you're going to have events that, overtop the flood culvert. The reason why that's viewed as acceptable is that the consequences, generally, of having a street flood or a culvert flood is, it's inconvenience to minor damage. That's kind of the magnitude of the consequence. So it's viewed as acceptable for, over the lifespan of the structure to not always be able to accommodate the flood volume, for example. For a dam or a major levee protecting highly populated areas, for example, that, of course, is not an acceptable level of protection because in those cases, if something goes wrong, if there's a failure or a collapse, you're talking about a catastrophe, either locally or on a broader scale. So it's not an inconvenience to minor damage, but it's something that would be immediately life-threatening to a lot of people. And so, of course, dams and major levees are built to much higher standards than stormwater culverts, as they should be. But the question is, just how high of a standard are they actually built to? And there are lots of claims that are made that these structures are, that could withstand the strongest foreseeable storms. But as a climate scientist, a meteorologist, my criticism comes from, okay, so how do we decide what the strongest possible storm is in a particular place? And what we see is systematic evidence that the largest plausible storm events have been underestimated. And I don't necessarily want to go into a lot of detail about all the evidence as to why that's the case, why we believe that's the case, but I do think it's fair to ask critical questions. And sometimes when you ask critical questions in this setting, you are met with radio silence, even among pure experts, if you will. And this is one of the few spaces where I've ever encountered that. So it's a long way of saying, yes, I agree with that sentiment, although I do think that there has been a bit of a change in tone in recent years towards more circumspection and a little more humility, which I think is a positive change in this space. So that's all I'll say about that for now. Maybe that's a topic for a more directed conversation later. But I do think it's an interesting piece. We are still working on the flood modeling for ArcStorm 2.0. We're still trying to get the funding to finish it. It has just been extraordinarily difficult to get folks interested in this. The extreme storm scenarios aren't that helpful in terms of emergency management and disaster preparedness planning and flood risk assessment in California unless we actually can do the inundation mapping. Ultimately, it doesn't matter so much how much rain falls on your house. That's not really the problem directly. The problem is how much floodwater does that rain translate to in a spatially explicit sense. So from spot to spot, who gets flooded and how deeply and for how long. We're still working on that. I think there's a path towards getting it done, but it's just taking forever. And it's frustrating for some of us who've been working on this for 5 or 6 years now, and there still hasn't been, enough interest to really get this out the door. So I think that in itself perhaps says something about the level of motivation to address these real challenges head on, which is not just a challenge of climate change, by the way. This was a problem even if our climate weren't warming, even if the risk of extremely large floods were not increasing. But it's especially so in the context of a climate that probably is increasing those risks. All right. There's a follow-up comment to Fran regarding the San Francisco Bay water level not necessarily being notable in a historical context. I don't know. I don't have that data currently, so I can't really comment on it until I see it. And yeah, another comment from Brad about what I thought about the New York Times piece about dams in California. No, I don't think it's alarmist. I think this is a real challenge. There's no indication that there's immediate structural problems on any dams in California, but when the Army Corps of Engineers, which operates some of these dams and is responsible for operating a number of critical pieces of water infrastructure in the United States, they have found, even according to their own numbers, that some of these events actually wouldn't fare so well under plausible worst-case scenarios. And again, I would challenge these folks that the way they're defining plausible worst-case is not actually as severe as the plausible worst-case truly is. So if, by their definitions, some of these structures are not necessarily up to the task under those conditions, then that raises larger concerns about what would happen if they've underestimated the likelihood of an event of that magnitude. Because, of course, this is the kind of context where you're talking about tail risk. So if you think about a probability distribution, some sort of a bell curve or something like that, we're way out in the low probability, high consequence part of the tail. That's what tail risk means. And as I mentioned, it's low probability but high consequence. So these, in any given context, a structural failure or a major structural problem that isn't even necessarily a failure but could compromise the dam's ability to spill water, for example, in a controlled fashion. These are unlikely, but, in some cases they're very unlikely, but they would be catastrophic if they occurred. And so how do we weight the fact that the odds are low, but the consequences would be extreme? And that maybe the odds, while still low, aren't as extremely low as has long been assumed in some contexts. And I think part of it is just a numbers game. Even if the odds of any given dam failing are tiny, there are dozens of major dams in California, dozens and hundreds of less major dams. So at some point, it becomes a numbers game under sufficiently extreme conditions. Even if you're 99.9% sure that an individual dam will be fine, probabilistically, when there's hundreds of dams, it only takes one. And so I don't think it's alarmist to be talking about this, no. As long as everything is rooted in numbers and folks are clear that nobody's talking about any specific imminent problem. This is just a general issue that has been considered for many years and may be becoming a larger problem as thinking about this. Man, I see that my connection is struggling again, so I'm going to give it pause. Okay, came back. Great. A few more minutes. I'm gonna run through a few more of these comments. What do you think the odds are that we'll see a plus 3 degrees centigrade El Nino anomaly this winter? What are the chances of having an El Nino stronger than 15, 16, or 97, 98? Honestly, I don't know. 97, 98, and 2015, 2016 are essentially the strongest ones we have in the observed record. So this one could well be comparable. Some of the models are predicting that it will be the strongest one on record. I don't know if I believe that. I do think there could be some potential over-prediction on the high-end members of these ensembles. But honestly, I don't know. And it's getting to the point where the median, the ensemble median, is getting pretty close to a record-breaking El Nino event. So, the dynamical models, I think, have a better handle on it than the statistical ones this year. But the dynamical models also do have a history of over-prediction for extreme events in some cases. So, in this context, specifically with El Nino. So, I don't really have any specialized insights. It's within the, I guess I could say it's within the realm of possibility that we could see a record-breaking 3-ish Celsius degree El Nino event this year. I don't know how to put the odds on it. I think the odds of 3 degrees Celsius is actually somewhat low, but probably not zero. But the odds of a strong to very strong El Nino event of a somewhat lesser magnitude is still high. And for context, plus 1.5 degrees centigrade would be strong. So, it wouldn't even take, even if we got up above 2 degrees centigrade of warming, that would be an exceptionally strong El Nino event. Alrighty here. Let's see what else there's going on. Just a few more comments here. Oh, there's a good one here. Let me see. Do you think the cold winter and record snow that we had in California, and that we did have those things, are essentially causing the mild summer that we're currently experiencing due to extra moisture and reflective snow keeping surfaces colder? I think my first answer is no, it's not, because the main thing that's happening is there's an unusually persistent trough near and west of California, and that's not directly influenced by the land surface moisture over California. That said, the secondary answer is probably yes, at least locally, particularly in the mountains, where there is still more moisture in the ground than there would normally be in places where the snowpack was heavy and melted late, and at very high elevations where there is still actually snow on the ground. So locally the answer is yes, but broadly across California the answer is essentially no. All right, here. All right, well, I think I'm actually going to wrap up with that. This was apologies for the technical snafus. I know that the audio did eventually align better with the video, so I'm going to try and troubleshoot after this ends, figure out why this is happening. As some folks have mentioned, it might be bandwidth, which would make sense. There's still a gazillion utility trucks on the street in front of the, so I think that garbage truck might have really done us in. I'm somewhat impressed there's a connection at all, because the lines were literally on the ground. So I was wondering if I was going to have to cancel. But glad we made it through. Thanks for watching, everyone. I'm going to try and go back to weekly conversations for a while, even though California, nothing incredibly exceptional. It appears to be on the horizon, but again, a significant heat wave is on the docket. And I will continue to host these throughout the summer as El Nino develops. We can talk more about that and other things as we experience in the western U.S. something that's very different from what's happening in the rest of the world right now, where it is in many cases record warm with bad fires, but not in the southwestern U.S. At the moment, which I think is a nice break for many of us. Just a reminder that you can still pre-order my extreme weather and climate calendar until August. That's still up there. I think I've been including some links. I'll throw one up there in the video at about this point once the rendering ends and I can edit it. And aside from that, I will schedule something for next week and see you then. Stay cool. I haven't had to say that yet this year, so do stay cool out there. All right, talk to you all later.